Hello everyone, myself Dr. Kavita Sharkar, Associate Professor, Department of Mathematics, Swami Vivekananda Institute of Science and Technology, Kolkata 145. In the last lecture, I have discussed coordinate transformation, Cartesian to spherical polar coordinate system, Cartesian to cylindrical polar coordinate system, and Jacobian. In this lecture, I am going to discuss divergence theorem. Gauss divergence theorem statement. If V is the volume bounded by a closed surface S and F is a vector function of position with continuous derivatives, then surface integral f dot n ds equals to volume integral grad dot f dv, where n is the outward drawn normal to S. Look in the diagram. N is the outward drawn normal to S. S is the closed surface and V is the volume bounded by this surface. Double integral over S f dot n ds equals to triple integral over V grad dot f dv. Here is a question. Verify the divergence theorem for f equals to 2x square yi minus y square j plus 4x z square k taken over the region in the first octant bounded by y square plus z square equals to 9 and x equals to 2. Let us draw the diagram. Y square plus z square equals to 9 and x equals to 2 is the cylinder whose axis is x-axis. The vector function given as 2x square yi minus y square j plus 4x z square k. What is grad dot f? Grad dot f equals to del del x of f1, that is 2x square y, plus del del y of f2, that is minus y square, del del z of f3, that is 4x z square. Del del x of 2x square y, partial derivative with respect to x, that is 4x and y as constant. Del del y of minus y square, that is minus 2y. Del del z of z square is 2z and 4x, that is 8xz. Now look in the diagram. Here we have taken three surfaces. S1 the lower surface, S2 the side surface, S3 the upper surface. For S1 the outward unit normal is minus I. For S2 outward unit normal is grad phi divided by modulus grad phi. For S3 outward unit normal is I. Let us find the volume integral. Grad dot f already we have found and put that, and let us take the limits. As because it is of first octant, so we have to take the z value from 0 to square root of 9 minus y square, y limits as 0 to 3 and x limit 0 to 2. Then you do the triple integration, what you have learned in previous lectures. And solving this, you will have look here, three parts are there. So let us take the first part as I1, second part as I2, third part as I3. Then let us find I1 as 36 and I2 as 18 and I3 as 72. And if we add them, then we are getting 180. Now we will find the surface integral. So on S1, outward unit normal is minus I and f is minus y square j. Why? Because on S1 x is 0. Look here in the diagram. This is S1, so here x is 0, and if we put x as 0, then we will have only minus y square j. Now I dot j is 0, therefore f dot n is 0. So if we find the surface integral, that is also 0. Next, let us find on S2. On S2, the outward unit normal is cat phi divided by modulus cat phi, and phi is y square plus z square minus 9. Grad, as we know, del del xi plus del del yj plus del del zk, and if we find grad phi, then we will get 2yj plus 2zk, and modulus of grad phi is square root of 2y whole square plus 2z whole square. So here 4 taken out and y square plus z square is 9 and square root of 9 is 3, and that 2 and this 2 is cancelled. Now let us find f dot n. F dot n equals to 2x square yi minus y square j plus 4x z square k dot yj plus zk by 3. As we know, I dot j, I dot k, j dot k all are 0. So we will get only minus y cube plus 4x z cube, because j dot j is 1 and k dot k is 1. Now surface integral over S2 f dot n ds2 is 1/3 double integral minus y cube plus 4x z cube ds2. We have to transform Cartesian coordinate system to cylindrical polar coordinate system. And we know the transformations. Y equals to r cos theta, r is 3, z equals to 3 sin theta, x equals to 2. As you have learned in the previous class. ds2 equals to modulus Jacobian d theta dx. Jacobian is r for cylindrical polar coordinate system, and for this question r is 3. Theta varies from 0 to pi by 2 and x varies from 0 to 2. So 1/3 double integral S2 minus y cube plus 4x z cube ds2 equals to 1/3. The x limits are 0 and 2. Theta's limits 0 and pi by 2. Let us put y equals to 3 cos theta and z equals to 3 sin theta. From there we are getting 27 common, and integration dx is x. Putting the limits 0 and 2, we are getting 2. Integration x dx, x square by 2. Putting limits 0 and 2, we are getting 2. From those two, 2 is common. Now the remaining integrations are 0 to pi by 2 minus cos cube theta d theta plus 0 to pi by 2 4 sin cube theta d theta. Applying the reduction formula for cos cube theta and sin cube theta, we are getting minus 2/3. Here also same, plus 2/3. So we will have 108. Now on S3, n equals to I, f equals to 8yi minus y squared j plus 8z squared k. Why? Because on S3, x equals to 2. F dot n equals to 8y. Why? Because I dot I is 1, I dot j is 0, I dot k is 0. Now double integral 8y dy dz, taking y limits 0, 3, z limits 0, square root of 9 minus y square, and just changing the order of integration dy dz to dz dy. First integrating with respect to z and putting the limits, we are getting y square root of 9 minus y square dy. Now let us substitute 9 minus y square as d square. So y dy is minus d dt, and if we put y as 0, then t is 3 because it is in first octet, so only positive 3 has been taken, and if y is 3, then t is 0. So substituting all, we are getting minus 8 integration 3 to 0 t square dt. Integrating, we are getting 8t cube by 3, 0 to 3, that is 72. So the surface integral is 0 for S1 plus 108 for S2 plus 72 for S3, total 180. Therefore, volume integral equals to surface integral. Hence, Gauss divergence theorem verified. Two problems are there. Number 1, verify the divergence theorem for the vector function f as 4xi minus 2y square j plus z square k taken over the region in the first octant bounded by x square plus y square equals to 4, z equals to 0 and z equals to 3. Almost the same questions except this cylinder direction is different. Draw accordingly and work out yourself. Question number 2. Use Gauss divergence theorem to evaluate for double integral over S x cube I plus y cube j plus z cube k ds, where x square plus y square plus z square equals to 9. Books you may follow. Next lecture on Stokes theorem.
For admission and course-related enquiry, please visit college website http://www.svist.org/